Hello everyone, today we're talking about modeling with functions, section 2.7 in our book. Modeling, this section can be very tough for most people. Reason being, most of the questions are word problems and they can be very hard to visualize. So as you see I'm going through it, I'm going to draw the question that the example is given us. And normally they won't come with pictures, so you're going to have to visualize it, draw it, and a lot of the equations you're going to have to research as well, look up. I'll have some for you, but LTA, stuff like that, it's simple research. You can find the formulas that apply to a particular problem, and you'll see what I mean in a second. So the first, they say the height of a right circular cylinder equals its diameter. Write the volume of the cylinder as a function of its radius. So like I said, first thing I'm going to do, I'm going to draw a picture. So cylinder, that's the best my cylinder is going to get. And it says the height equals the diameter. So the diameter, right, is the length across the circle. And they're saying that this diameter is the same as the height. So I'm just going to label them both D. And then it wants the volume of the cylinder only as a function of the radius. So volume of a cylinder is pi r squared h. Okay, reason being pi r squared is the area of a circle, then you multiply it by the height of the cylinder, that's how you get the volume. Right, three-dimensional. We know h, and we can find r because the diameter is just 2r. So they want the volume only as a function of its radius, so that must mean the volume equals pi r squared. And then instead of h, the height, I know the height equals the diameter. And since the diameter is 2 times the radius, right, the radius being half the distance across, then I can plug in 2r. So my volume equals, and if I simplify, 2 pi r cubed. So there's no express formula for these problems. That's why they can be so difficult. You kind of got to think through the problem, draw a picture to help you visualize it, and then try to solve. Next one. They tell us a wire of length x is bent into the shape of a circle. Right? So if we have a wire, let's say length x, they're telling us that is the same, right? So the whole circumference of the circle, right? That circumference is x, right? I just took this and I bent it into a circle. Now they might not look the same length, but we're going to assume the same length. They just took that wire length x and bent it into a circle. So they want first to express the circumference as a function of x. Well, we know the circumference, right? The distance around the circle is just going to be x, right? Because we knew the length of the wire was x. So the circumference of the circle must also be x. We didn't change the length of the wire as we bent it. Part B, though, they want the area of the circle as a function of x. So, since area of a circle equals pi r squared, we can figure out that since the circumference equals x, then the circumference must be pi d, right? So the circumference formula is pi times the diameter, and then x must be equal to 2 pi r, since the diameter is equal to 2r, and solving for r, x over 2 pi. So I did this little work over here. So I can plug it into my equation here for r and have my function in terms of x. Right? It doesn't want my function in terms of r, it only wants my function in terms of x. So I had to solve the circumference for r in order to plug it into the area. Again, they did not give us this formula, so I just had to think through the problem, think about what equations I'm going to have to use, and then think about what the question is asking me. So I'll take r, plug it in. So pi times, and then instead of r, I have x over 2 pi, and that's all squared. Now, since this is division, I'm allowed to distribute the square. Okay, and since this is multiplication, I can cancel one of the pi's with one of the pi's in the denominator, right? Because that's just like pi over 1, so I'm allowed to cancel one of those with one of those. So that means the area in terms of x is x squared divided by 4 pi. Answer to part B. And one more example. So they tell us a square of side x inches is cut out of each corner of a 10-inch by 18-inch piece of cardboard, and the sides are folded up to form an open-topped box. So what I did here was first I'm going to draw the picture. So we have a piece of cardboard, right? They tell us it's 10 inches by 18 inches. And I'm going to move that down. Okay, so they tell us it's 10 inches by 18 inches. But we have cut out this square of each corner. So basically what they're saying is they cut out this little corner. Right, and it's an x by x. Right, so we kind of have this box type. Kind of like a Christmas present box that you would get, you know, where it's got the top and the bottom, normally that shirts and stuff will come in. So they've just cut this side X out, and they're folding it up, so we just have an open top box. And they say it's a square, so that means all of these dimensions are X, whatever X may be. Okay, no big deal. They're just telling us we're cutting an X by X square out. So we just know that those two sides are equal. I also drew this in a couple different views, trying to give you an idea of what it looks like. So from the side, right, it's kind of going to look like this, because they're going to fold these up. And also I wanted to let you know that this side then, the whole side length, right, after we take our x's out, is going to be 18 minus 2x. So that'll be this length here. Right? Because after we take those x's out, must subtract 2 x's from 18. So this length here is 18 minus 2x. Right? So I've just taken the length, wrote it down there with a height of x, because that's basically the height of the side that I'm folding up. Then I also wanted to show you the front versions, like if I was looking from this way. This way we're kind of looking this way at it. This way we're looking the narrow side at it. And that means that from here to here, maybe if I do it in a different color, we get 10 minus 2x. Right? Because the whole length was 10, but I'm taking 2 x's out. So that means this narrow view is 10 minus 2x. So it gives us the length and width of our box at 18 minus 2x and 10 minus 2x with the height of the box x, whatever x may be. So now that we kind of see the picture they're talking about, cutting that little square out, let's go answer some questions about it. So it says write the volume as a function of x. So we're only allowed to have the variable x in our function. Minus the volume, of course. So volume equals length times width times height. Then let's just plug in what we know. Well, we know the length, 18 minus 2x. We know the width, 10 minus 2x. And we know the height, x. So I just simplify by multiplying it all out. And we get 180 minus 56x plus 4x squared times x, which simplifies to the equation 4x cubed minus 56x plus x squared plus 180x. So there is my volume in terms of only x. So all I did was multiply length times width times height, right? Length times width times height. I got my volume. Then they want me to find the domain of the function. So I'm going to go ahead, I'm going to graph this for you. And I'm going to show you the domain of the function. So let me go into Desmos so I can show you the best looking graph that I can find. You can also do on TI-83, that's what I did. And then we can find the domain of the functions, then we'll find the maximum volume. So we can see that we kind of have, and the window's not so great on here, but we can see that we kind of have three different parts of this, right? With my domain, I have to have a positive value, right? Because I can never have a negative, I can't have a negative length. So I know that my domain must have the positive value. We're not worried about anything to the right, because if it's bigger than 5, then 2 times 5, it's, right? So if my x is bigger than 5, then this length won't work, right? X could be at most 5, because 2 times 5 is 10. So I know that x is the largest value I can take is 5. Smallest value I can take is 0. Let me go ahead and type this in the TI-83 as well to show you maybe a little bit better view with the domain, with the length and width, the window a little bit better. And the window I used is negative 10 to 10 for my x, and negative 10 to 200 for my y, giving me this graph. So this is just the same graph we saw in Desmos. It's hard to see that it goes through the point 0, 0 here, but I can check my table to show that it goes through that point 0, 0, goes through the point 5, 0. And I can't go any larger because then my my width would be, my x, but the length of the squares would be even longer than the side. So I know that the largest value x can take is 5. The smallest value x can take is 0. So my domain I can include 0. That just means I'll have a volume of 0. And I can include 5. That also means I'll have a volume of 0, right? Because it'd just be a flat cardboard piece. There'd be no width, there'd be no height to it. So it'd just be a flat, like, piece of paper, right? So it wouldn't have any volume. So at 0 and at 5, it wouldn't have any volume, but we have all the points in between. So that brings us to the next part of the question, which asks us to find the dimensions that'll produce the maximum volume. So to find the maximum volume, I'm going to go back to my TI-83. I'm going to find the max, and then that x value will give me the x that I can plug in to find the dimensions that yield the largest result. So I just got to do second calc. it's a maximum here. Left bound, right bound, and I'm going to guess right near the top. So pretty much an x value of 2 is going to give us our largest volume of 168. So if I find the dimensions with an x value of 2, so the dimensions of my box, if I plug 2 in for x, right, the graph showed us that an x value of 2 yields the maximum volume. So if I plug that in, that means my length is equal to 18 minus 2x is equal to 14. So the length of my box will be 14 inches. The width is equal to 10 minus 2x, or 10 minus 4. So the width is going to be 6. And then my height is going to be x, right? My height is x. So if I take 14 times 6 times 2, that gives me the dimensions of 168, which checks what our graph showed us, that the maximum volume our box can reach is 168 inches cubed. I believe they said inches. And since we're talking about volume, the units are cubed. So these questions, very difficult to get the concept, but I think once you get it drawn on paper, I think the question becomes a whole lot easier. So go ahead, try the example problems that accompany this on the PowerPoint, and like always, we'll go over them tomorrow, so bring any questions you have.